Okay. What about signed numbers? I carefully talked about the natural numbers. What about signed numbers? So what I want to do is to come up with a representation for negative numbers, and there's lots of different choices I could make. I could, like in decimal, how do we represent negative numbers in decimal? We just put a special character in front, a minus sign to indicate negative. What I want to do is come up with a binary representation which allows me to use addition to do both to deal with both positive numbers and negative numbers. In decimal, when you do see a negative number and you're trying to say what is 3 plus minus 4, I actually have to go do a separate operation called subtraction to do that. I don't want to have that complication, right? Suppose I have so in the natural numbers, this is the 8-bit representation of 1. Now what I would like to do is to just sort of scope out as best I can. I want to come up with something that I would add to 1 to come up with the 8-bit representation of 0. So I'm going to use regular base 2 addition to do that. Someone suggests to me a string of binary digits I put here such that if I added it to 1, I'd end up with 0. And then what I'm going to say is this is the representation of 1, this will be the representation of minus 1, and when I add them together I'll get 0. Okay, well, what do I have to add to the binary digit 1 to get a 0? 1 plus 1, well, in binary that's 2, which is 10 in base 2, so that's 0, carry the 1. Okay, now what do I have to add on the next column? A 1, so forth and so on. So I hope you can sort of see that if I restrict myself to 8-bit numbers, this is the 8-bit representation for minus 1. Everybody with me on that? And I'm trying to have this sort of criteria that I'm going to use addition always, even when I'm dealing with negative numbers. So let's generalize that. Suppose I have a, and I want to add it to minus a, and I'm going to get 0. I'm going to rewrite this slightly. I'm going to say minus a is equal to 0 minus a. I've just moved the a to the other side. Happy with that? Now I'm going to rewrite this 0, okay, as 1 plus minus 1 minus a, which I'm going to think of this now as basically as 1 plus minus 1 minus a. And so say, this is a lot of work, Chris, for doing very trivial manipulations. But now we're going to come up, I'm actually going to compute this. Okay, and then I'll be able to come up now finally with an actual binary representation for minus a that will let me use addition whether I'm dealing with negative numbers or positive numbers. Okay, so keeping that in mind, I'm going to slide that up just a little bit. And what I'm going to do is say, well, what was minus 1? Right, it was all 1s. And I'm going to subtract from that a. So I have, a, these are the individual bits of a, all the way down to a0. And I'm going to actually subtract that, and here I'm just going to use regular binary subtraction, although I won't have to do that in my hardware. What is 1 minus a bit? Suppose a0 was a 0, what would be 1 minus 0? A 1. If a0 was a 1, what would it be? 1 minus 1 would be 0. Okay, so what we end up with down here is the complement of a0. Everybody, yeah. If this was a 0, then 1 minus that, which is 1, vice versa. And so what we end up with is basically the complement of each of these guys, a7, complement of a6. I'm going to represent that now as the complement of a. So this tilde sign is basically says that's the bitwise complement. I'm going to take all the bits in the number, in the representation of the number, and simply invert them. If they were 0, make them 1, so forth and so on. Everybody happy with that? Okay, so what I'm going to do that, and now what I have to do, that's the result here. I'm going to add 1 to it. So the notion of flipping all the bits, that's called 1's complement, just complementing all the digits with respect to 1. I add 1 to it, so that's called 2's complement. So this is the representation of a minus number. Okay, complement and add 1. So you get very used to that. All right, so 2's complement, that's what every computer that I know of uses 2 complement, representing integers with a different representation for floating point.